ecosystem, and it's most I'm like it's one of the demanded skill set. Okay. Okay. Yeah, Karthik, demo will clear most of the doubts. Okay. I mean, like, do you mean the demo on the Impala? All right. Okay. So, all right. As I said, like, I'll show you a demo on the next session along with Pig. Okay. So after completing today's topic, that is Apache Pig, and basically we are going to cover only the basic today because this is a new language. It's a new language that you'll be learning in Hadoop. So if you're not familiar with any programming language, don't bother about anything. Uh, by the time you end with this topic, you'll be much familiar with other programming languages as well. Okay, so after completing this topic today, you should be able to list the ways to invoke Pig, and you should be able to describe the data structures used in Pig, and you know how to use the load operator to read data into the Pig, and you can pass input parameters into the Pig script. Also, you'd able to understand what is the how to use the output operator to write the data from Pig. Okay, right. So let's go the slide. All right. So Pig overview. So overview Pig, or let's say Pig Latin. See, Pig Latin is a language, is a high level language designed to remove the complexity of core MapReduce applications. Okay, so I always kept telling you guys, if you don't understand MapReduce, it's okay, because that needs a little bit Java background, and that is the reason I skipped a few demos as well. But Neha, she requested for one complete cycle of MapReduce. So I'll show that by the end of this course. Okay. Anyway, so running a MapReduce job or developing a Java MapReduce is a bit hard, right? It takes time. So in all the session, I used to keep this like I used to chant this thing. So this is one of the tool that can be like you'll be learning a new language, and basically Pig converts its operators into MapReduce codes. Okay, so instead of needing Java programming skills and an understanding of the MapReduce coding infrastructure, people with little programming skills can simply invoke sort or filter operators. Okay, and that is without having to code any MapReduce application to accomplish those tasks. Okay, and about the overview, and see, one of the strongest feature of Pig is that the developer or analyst, uh, they does not have to depend solely on the Pig supplied operators. Okay, and it is possible to extend the language by coding one's own UDF. Okay, that is user defined functions. Okay, and Pig was developed by Yahoo. Okay, so can you give me a quick answer? Who developed Hive? All right, great. So Facebook have developed Hive, and Pig is developed by Yahoo. Okay, so you're learning most of the modern languages, but it is developed a long time back. So let's move on to the next slide. So Pig execution. See, executing a pig can be like in interactive mode or even in script mode. Okay, so both of these have to have two options. Okay, so local mode gives you access to data which is in your local file system. I have clearly mentioned that in the slide. It would be very easy for you guys to look at that as well, for better understanding. Okay, and it also runs in a single Java virtual machine. Okay, I'll repeat that. It runs in a single Java virtual machine. Okay, basically this in uh, this mode is normally used for testing against a limited amount of data. Okay, so the second option would be map reduce mode. That means like that runs on a Hadoop cluster and converts the pig statement into map reduce code. Okay, so we should know this difference because you will be expecting you can expect a lot of questions from pig and hive. Okay, so in today's trend, most of the big data interview they ask much questions from hive and pig and scoop and flume as well. Okay, and some questions could be you can expect from impala as well, but only there is a small changes in architecture, right? All right, so let's get into pig execution. See, to invoke pig in an interactive mode, you must just execute the pig, and you are then placed into the grunt shell. Okay, so you'll be using a grunt shell, which is similar like CLI. Okay, by default, you will be running in MapReduce mode. But to execute pig interactively in local mode, you need to execute. You need to type in like pig hyphen x local. Okay, and to invoke a pig script, you need just include the name of the script file when you invoke pig. Okay, for example, in the slide, to run a pig script called myscript.pig in local mode, simply execute pig hyphen x local space myscript.pig and semicolon. That's it. Okay, and to run the same script in MapReduce mode, execute pig myscript.pig. That's it. Okay, and it is also possible to invoke pig by using Java command as well. Okay, but we are not going to show that. Basically, we will be working with the grunt shell. Okay, and in production we use grunt shell. Right. So let's move on to the next one. Anyway, just take a look at the slide. Maybe it would be good if you do some visualization, visually compare the things. The slide. So what I discussed is we can use uh, execute the pig in an interactive local mode. Also, I told you like you can execute pig in an interactive mode using MapReduce mode, right? And also you can execute a pig script file as well. There are three methods. Okay. All right. So let's move on to the next slide. Okay. So first look at pig data. So as you might expect, the pig language has data types. Okay, and basically they are used to define individual fields. Okay. So some examples are like int for integers and char array for basically character array for string data, and double and floats for numbers with decimal points. I hope you're familiar with. You should be familiar with these things, right? Anyway, you can just stare at the slides. You can understand very easily. So fields are basically they are grouped together into tuples, or you can call as tuples. Okay, so you might think of tuple as a row in a relational data table, or a record in a file, right? So pig has a greater flexibility over a relational table, basically, which is in that tuples which do not have to contain the same number of fields, right? So that makes sense, right? And tuples are basically grouped into a bag. Now this is so this is where it can get a little complex. Okay, so I just said that a bag is a group of tuples, but a field in a tuple can actually be a bag that contains other tuples. Okay, that makes sense, right? Okay, so in this case,
Karthik, I didn't get that. Can you please repeat that?
what I said is like tuples can be grouped into a bag. Okay, and it can be the bag is a group of tuples, but a fields in a tuple can actually be a bag that contains a lot of tuples. I'll explain. Maybe I can give you a better insight. So, see, the bag that contains the tuples basically that to a row in a relational table. Okay, and this is basically known as outer bag. Just go with the arrow. It's very easy. So it is also known as relation, and and here the map data is also supported in pig. Say a group of a group of tuples can be a bag. Okay, so just keep that as a mind note. Okay, so like I said, like map data is also supported in pig, and a map is basically a set of key value pairs. Okay, so accessing a map with specify key basically will return the value associated with the key. Okay, so what I mean to tell you is, if you want to access this map with any specific key, it will return the value associated with that particular key. Okay, so your map is a set of all about a key value pairs. Okay, so now let's slowly get into pig Latin statements. Right. So we have pig Latin statements basics here. So all right. So before I begin that, just take a look at this. If I'm not clear. All right. So let's move on to the next one. Right. So let's move to the next one. Right. So pig Latin statements All right. So this basic is so most pig operators take a relation. Okay. Relation means like an outer bag, right? In the previous slide, we have mentioned about that, right? Relation is an outer bag, right? So, pig operators take a relation as input, and in turn emits a relation. That means like it turns and emit as a relation. Okay, and the exceptions are the load operator. So I have mentioned that in caps. Can look at the very first point. I'm like in the first point. So the exceptions are the load operator, basically which only emits a relation uh, after reading the data from the from any from some source. Okay. Uh, so the store operator basically takes a relation as input, but it writes the data in a relation to a file. Okay, and the dump operator, which is like the store operator, and it takes a relation as input, but it writes the data value as the console. Okay, let me repeat it. Maybe if you're not let me repeat that. So what I said, like the store operator basically takes a relation as input. Okay, and it writes the data in the relation to file, and the dump operator, uh, which is also like the store operator, but it takes a relation as input but writes the data value to the console. Okay, so you understand the difference, right? And all pig statements, both in a script and when running in a grunt shell, are basically terminated by semicolon. Okay, so in a script, it is possible to include comments. So I have, and then the third point, we are discussing more about the comments. So all statement between forward slash star and star forward slash are commented. So you might note that that's very easy. So so here double dashes will basically comment the rest of that line. So that's pretty easy, right? So take a look at this slide. And most of the questions you can expect from the slides, guys. So if you want, you can give a little try, because there is a hell lot of openings are coming up. You can update your resume, and you can give a try for any startup or big companies as well. Right. So let's move on to the next slide. Right. So input. See, the load operator is basically used to read the data from a source and place that data in a relation, right? We have mentioned in the very first point, the load data operators emits a relation, right? So, since there are a variety of ways that data can be stored, there are going to be a variety of functions that can be used with this operator. Okay, so pig supplies four such loads basically. It says four load functions. So you can supply your own as well. So the default load function is pig storage. Okay, it's case sensitive, guys. Pig storage. Okay. So the default load function is pig storage. So just make a mind note. You can expect this question because this is my favorite question. I keep asking this question. what is the default load function in pig. So the default pig load function is pig storage. Okay. And this basically this reads the data that is in a delimitated format, delimiter being the tab character. Okay. And if some other delimiting character is to be used, then that character is supplied in a single quotes. Okay. And the text loader uh, basically it reads in a line of text, and this line of text is placed into a single tuple. Okay. And the bin storage function is used to read data in a machine readable format. Okay. There is a bin storage function. Basically it is used to read the data in machine readable format. Okay. So can you give example what could be the machine readable language looks like, or any format is there? Any example? We have covered that in the earlier stages of this course. What is machine readable language? Any good example, guys? All right. So any idea about the semi-structured data? Any idea about the structured data or unstructured data? All right. So any unstructured data? Who use the unstructured data basically? All right. So I'm not going to take much time. All right. So let me explain that. See, machine data is something that you cannot read, right? So that means like JSON, right? It can be XML, it can be or any other format. Basically, you can read in any docs file or something. You cannot read JSON, right? So JSON is one of the best example for machine readable format. So this is basically used by Pig internally to store temporary data. Okay, and there is also a JSON loader. Okay, so this basically loads the data in a standard JSON format. So let's look at the example. Like A equals load, and that's the path basically. So it's just the path. It's just a path, and using the pig storage, and it is delimited by, right, and basically it will read the data from a file, and data file which is located in the slash data dir, right? So after load, it's the path is the location, right? So basically it will read the data from a file, and data file is located under the slash data dir, right? Since this is the big storage function is being used here, the data is expected to be delimited format with the tab character as being the delimiter. Okay, so the results are basically placed into a relation called A. Okay, so the capital letter A here is the result, and it is called as a relation. Okay, take a look at the slide if I'm too fast. So we discussed about the load operator and some functions. Guys, a quick question. Can you tell me which is the default load function in pig? Good. Right. Right. Good. Okay. Great. All right. So we discussed about the pig storage, which is the default function. I'm repeating this once again for you guys. And then we discussed about the text loader. Basically, it reads the line of the text, and this is basically a line of text which is placed in a single tuple. Okay. Also, we discussed about a function called bin storage. So, guys, any idea about like what reads basically in bin storage? What is the use of this bin storage? Which type of format it reads? Any idea, guys? Right. So it's okay. You are taking much time. Let me explain that. So bin storage is used to read data in a machine readable format. Okay. So you could be questions could be like that. What kind of which function reads the machine readable format? So you can answer them like bin storage. All right. And we also discussed about there is a JSON loader. Basically, this loads data in standard JSON format. Okay. There is a difference between bin storage and uh, JSON loader. Okay. Right. So let's move on to the next one. Load operator. All right. So let's continue the load operator. So as I said, you can code your own load function if your data is in some proprietary format, and basically it is not supported by the supplied load function. Uh, okay, so there is a load option that we should discuss here. Okay, so so this option basically provides a schema for your input data, right? So to specify a schema, you code as like your schema info, and after that the load function, right? You understand what is schema, right? I'm like you guys. If you missed something in Hive or SQL class, okay, you are not into SQL class, right? Okay, we have created a table, right? Create a table, something something. After that, we have write a name as string name as so such things. Okay, so anything on the columns, if you mismatch these columns, or if you're trying to match something in the column, that would be called as schema. Okay, so continuing with the schemas which is provided for your input data, you should specify a schema as a code. Okay, so your schema info should after the load function. Okay, take a look at the example on the slide. So continuing with the similar example, like a equals load and then the path using peak storage and delimited by comma, and as then comes the f1, right? F1 is some column, and basically the type is data type is int. That means like it's an integer, right? And then the next one is f2, which is char array, that is character array, right? The third one is f3, which is a float, that's big numbers, right? So these are the schemas, right? You have to mention that after the load option. Okay, so you would read a comma delimited file and interpret the first field as integer and associate it with the name of f1. Okay, and the second field would be a character array, and the third is a float, right? So if you do not supply a schema for the pick storage function, uh, then the fields are not named, and all the fields default to the byte array for their data type. Okay, and the JSON loader function requires a schema. Okay, so if you are working with any Twitter sentiment, you will be given as a JSON format, and you will be working with the JSON loader function. Okay, and for that you definitely need a schema. Okay, and the interviewer may ask you some questions to check whether you really worked with pig. You can expect such questions like, what will happen if you don't provide a schema in a pig storage function? Okay, the answer could be like, then the fields are basically not named, and all the fields uh, default to byte array, okay, for their data type. Okay, 2 points you should say: fields are not named, all the fields byte array. Okay, so remember these points, right? Makes sense, right? So take a look at the. It's 9 o'clock. Take a look at this slide. We'll move on to the next one. All right, so good to go, right? Right, so let's move on to the next one, accessing data. Right, so you have seen examples where the load operator was reading the data from a specific file, right? So, but it can go beyond that. So, if only a directory is specified, then the load operator will read all the files within that directory. Okay, so it's very simple, guys. So in first point, we are basically using a load operator, basically for reading the data from a specific file. And the next one, we are giving a command. Basically, we have not mentioned any file here. We are basically specifying a directory. Okay, and all the files in my directory are read, right? So you can see that all the files will be read by the pig. Okay, so that's very easy. So you can expect what this kind of question, like how to access data from a directory, or you can expect questions like how to access all the files from a directory. Okay, so this is very easy. Let's move to the next one. All right, so this is much important to notice here, because it comes with sensitivity. I mean, like case sensitivity. So the names of relations and fields are basically very case sensitive. And at any point in time, if you are given any errors, just make sure that you are typing the right name, right file, and the right sense, because it's case sensitive. Okay, and function names are also case sensitive as well. And but the keyword and operators names are not case sensitive. Okay, so the keyword and operators are sorry, operator names are not case sensitive. Okay, other than that, everything is case sensitive, both names of the relations and fields and function names. Okay, so take a look at the slide. So in the first example, like we are using the same query, but with small changes in the case sensitive. The first one is the data. So the first data and the second data is two different relations, not the same one. And in the schema, you remember what is schema now. So in the schema, the F1 or F2 basically that are basically a different fields here. Okay, so I have mentioned F1, that is a small letter, and the caps letter in F1. So basically both are different fields. Okay, and we also have function names, which is also case sensitive. In the next command, we have pig storage. That is the function name, right? We have discussed what is the default function. It is pig storage. So pig storage is also case sensitive. Okay, so I have made I mean, like I just colored it for your easy understanding. So if you type in a small letter, you will get you will be given errors. Okay, and you know how to debug that as well. All right. So the third one is about the keywords, which is not case sensitive. Okay, so like you can use load, using, ask, group by, filter, everything, but these are not case sensitive, and basically pig accepts that. Okay, all right, so good to go. Let's move on to the next one. All right, so field reference. So so field reference, basically fields are basically assigned names through the use of schema. Okay, and fields may be referenced by their names. Okay, so I have made a nice example there. So so basically maybe fields are basically assigned through the name using the schema. Okay, and it will be referred as their names. Okay, and see, but a field can also be referenced by positions as well. Okay, and this accomplished by specifying a dollar symbol and a number. Okay, so so field numbers basically start with 0. So with the schema of name is character array, age is integer, salary is basically float. So the age field could be referenced by position as $1, right? And and if a schema is specified when the data is loaded, then the fields can be referenced by positions. Okay, right. So take a look at the slide. So I have mentioned that fields can be referenced by position, also by its of schema and by its position, right? So we have both joins do the same thing, like A on big bk num or B on bk num. Okay, I hope you guys are familiar with joins, but if you're not familiar with joins, that's okay. If you've gone with Hive, it's the same thing. Hive has its own joins as well, right? All right. So let's move on to the next one. Okay, it's BKNM is just a schema name. It's a field name. See, here we are using an example like uh, consider that you're having a library, okay, and you lots of books, okay, and you have a books.csv file, and you have previews.csv file. So basically, in the first line, you have used that, you have loaded that, and you are declaring the fields as bk num in the books. Okay, so that is an integer, and the title of is a character array. Okay, so basically, in a books.csv, you will find two columns. Okay, one is book number, and another one is title. Right. So have the bk num is just a short form for that. It's a schema, and the okay, and the next one in the B, basically we are loading that using pig storage, and we have a book name and also a reviewer character array, right? So we have book number and also the reviewer. Okay, so we are okay with that, right? And in the C we are using basically a join. The join is basically with the beginum and a on a beginum. The first one with the uh, that is beginum of books.csv, and joining the bk number of reviews.csv. What I'm coming to say is, like, basically we have two things in common in books and reviews. That is book number, right? So basically we are trying to join a book number of A along with the book number from the B. So what is what is the assignee as of B is reviews.csv, right? And in the D we are joining on $0 on A and dollar B, on the $0 from B. So means like both joins do the same thing. Almost it's the same thing. We are repeating it. Okay. And also I have mentioned that if a schema is not specified, then the fields can be referenced by the position. Okay. So this dollar is basically referenced by the position. Right. So let's move on to the next one. I hope I cleared Sedu. That's very simple thing. Right. So this is something very important for any language you learn. So data types. So in big data types, basically these are the listed big data types and a description of each. So I am not going to read each type to you, but you can use this slide as a reference. And data types that have not been mentioned is long, which is a 64-bit integer, and a byte array, which is a blob type. Okay. Right. So take a look at this. Maybe you can read it a little louder. You have data types and description and example here. So you'll be working with this a lot because this comes. You will be working with this data types for creating the schemas, right? So int, long, float, double, character array, byte array, tuple, bag, map. All right, so let's move on to the next one. Okay, let's go to the next slide. So we have operators like any other programming language. Basically, operators in Pig Latin, it allows for the normal arithmetic operator, and it is found in any other programming languages, right? So examples like addition, subtractions, multiplications, and divisions. So to start with any language, I would request you guys to start working with this mathematical things. It's arithmetic, basically. It's very easy. If you go with that, then I'm damn sure that if you practice 10 to 10, 5 to 10 times, then you can rock any challenge. Okay. Also, here included in modulo, basically. So in binary condition, it's essentially a shorthand notation for an if then else. Okay. And here also we have x equal 5. That means like or like 1 to the 2, or if x equals 5, then 1 is returned, right? So otherwise 2 is returned, right? So it's all based on the conditional processing, right? So conditional processing is handled by boolean operators, and like and or not. These are all boolean operators, right? And fields can be compared using the comparison operators. And equal to is written as equal, and not equal is written as yeah, hyphen an equal symbol is, right. And this is null, which is failed in uh, which is the field is null, basically, right? So you guys, you should be familiar with this, right? Is null, not is not null. This should be clear to you guys, because uh, I just took a screenshot and just copied it. I didn't do that manually. So these two things you will be working in comparison. That is null, is not null, and the rest of the things you will be working. So it's very easy, guys. So you can have a hands-on, maybe the next session. And moving on, we have parameter substitutions. This is very much important. See, basically, the parameter substitutions is parameters can be passed to a pig script. Okay, and this allows a single generic script to be used for specific situations, like values that are not common across all executions of the script, and can be changed for each invocation of the script, like that. Okay. So within the script, parameters are referenced by preceding the parameter name with a dollar symbol. Okay, and there are two ways to pass parameter values to a script. Okay, and parameters can be set to values on the command line when the line is in when the script is basically invoked, or the parameters along with their values can be defined in any any parameter file. Okay, so assume that within your pig script, that is myscript.pig, you have the statement, yeah, statement like a equals load, and then starts with path, that is $dir slash myfile.txt. Okay, so your script is assuming that a parameter by the name of the dir is going to be passed. Okay, so now let's look at the two ways that that the value of dir can be specified. I hope it should be visible. It should be. So one is executing pig hyphen param space dir, and it comes dir equal to slash lab files. So my script.pig basically passes the dir to your script with the value of slash lab files, right? So the load statement in your script expands, basically it expands to the entire path, right? So a equal to load and then path comes like uh, slash lab files slash my file dot text, right? So basically it's expanding the script. And a second technique is to have a file that has parameter values. Okay, so assume that the name of the file is myparams.txt. Okay, so within this file you can code a statement like dir equal to slash lab files. Okay, and then when you invoke your script, uh, you would execute pig hyphen param underscore file, or like my params dot text file, and my script dot pig. Okay, so it makes sense to you guys, right? Or it's overloaded. All right, so let's finish up with the next slide. That is output. So this the basically the store operators saves the results to a file. Okay, so it is built in functions and similarly to the load operator. Okay, and basically it is to determine how output data is to be formatted. Okay, so pig storage is once again the default, and the tab character is default and delimiter. Okay, so store operator is basically used for saving the results to any file. Okay, and we have bin storage, and this bin storage is basically used by pig for any temporary files. Okay, so you can expect such question like how will you store a temporary files. So you can mention bin storage. It's temporary, guys, and it directly goes to the bin. All right, so we have a pig dump here. Basically it stores the data as tuples in a human readable UTF-8 format. Okay, so UTF-8. So this is a system. This will be the system default language, basically used for any human for better human readability. Okay, so if you're working with any localization in your projects, you can always select this UTF-8 format, and you can read the contents, right? Right. So moving on to this pig. So we pig dump basically that stores the data as tuples for human readable in UTF-8 format. Okay, and okay, and the next one is JSON storage. Okay, so JSON storage writes data with JSON format. So the name itself, it's very easy for you guys to understand, right? So as with with the load operator, you can code and specify your own function also. Okay, so the format of the store operator is store alias name into directory and using function. I have mentioned there. I'm like you can see that very clearly in the slide. So the format is store alias into directory and using function. So you just remember the symbols that I have mentioned here. So once you start using it, it will be very easy for you guys, and you can remember any point in time. All right. So this format, this basically this is specified directory will be created. Okay, and if it is already exist, then the operation will fail. Okay, and files will be written into the directory which will be on any will be on the format of part hyphen n like that. I'll type that because I have not added that in the slide. Okay, so this n is n's are basically a numeric value. Okay, so that could be a tricky questions if you expect if you get such kind of questions like what happens if you have a file already exist, then you should mention them that the operation will fail and it will write the directory with the format part hyphen n like that. Okay, and as stated before, the dump operator basically writes the results to the console. Okay, dump. Okay, so this is an operator which writes the results to the console. Okay, and basically it is designed for debugging and testing purpose. If you are looking anything on big data testing or data scientist as in testing or any Hadoop tester, you will be debugging with uh, you will be basically debugging and testing a lot, right? And you'll be working with a lot with dump operator. Okay, in production you'll be using that as well. All right. So moving on. So that's about the today's topic. So we have very few. We covered the basic thing, basics of Apache Pig. I don't want to confuse you guys by covering entire thing. So I hope it's not confusing you guys. So in today's topic, having completed Pig basics, uh, so you should be able to list the ways to invoke Pig, and you should be able to describe the data structures used in Pig. Also, use the load operators to read the data into Pig. So we also have passed the input parameters into Pig script. So we are also discussed about the use of output operator to write the data from Pig, right? So any questions so far from this? All right. Okay. So no questions. Right, guys. So that's the end of today's session. So in the next session, we'll be looking into little bit. We'll do a little bit more on the hands-on, and we'll cover little Pig Latin language. These are very basic, so I would request you guys to go over this once again. I'll send you the link, the recorded session link. So go over that. So we'll catch up tomorrow at 8 o'clock. All right. So thank you so much, guys. See you tomorrow. Good night.